Good morning everyone. I hope once again you are doing study at home in proper way. So friends, in our last lecture we learned about the kinetic energy of rotating body. We obtained the relation kinetic energy of rotating body equal to half I omega square, where I is moment of inertia and omega is angular velocity. Now the same article we have to continue with the kinetic energy of rolling body. We obtain the relation for kinetic energy of rotating body. Now we have to obtain the relation for kinetic energy of rolling body. First was rotating, now it is rolling. What is the difference between rolling and rotating? The rotational motion, it is about a fixed axis at one place, but rolling, it is the motion of combination of rotational and translational. एखाद्या डोंगरावरून जर आपण एक गोल दगड सोडून दिला आणि एक चपटा दगड सोडून दिला, काय होईल? तो जो चपटा दगड असेल तो घसरत येईल, स्लाइडिंग मोशन or just translational motion. But what about the round shaped stone or object? The round shaped object साठी काय होईल? It will move in downward direction and again it will rotate about its own axis. तो आपण कसा येईल खाली म्हणू? तो घरंगळतील. That rolling is, मराठीमध्ये त्याला शब्द आहे घरंगळतीने. तर combination of rotational and translational, it is called rolling. See here one example. If this is an inclined plane, inclined surface, if we keep this object, if I apply some force this object, it will just slide down. It is not rolling, it is having translational motion. So this is just translational motion, this is translational motion. But what happens to the round shaped body? This is a sphere. If we put this sphere here, see here motion of this sphere, this starts rolling, this is the rolling motion, means it is combination of translational and rotational motion. See here piece of chalk, if we put here, it starts rolling. So this is combination of rotational and translational motion, it is called rolling motion. Here we have to consider expression first for kinetic energy of rolling body and then for its velocity, that is speed at the bottom point, and also its acceleration. तर रोलिंग मोशन म्हणजे काय लक्षात आलं? जी कॉम्बिनेशन असते लिनियर मोशनची आणि रोटेशनल मोशनची, तिला म्हणायचं रोलिंग मोशन. इथे एक ऑब्जेक्ट घेतला. हियर वी हॅव टू कन्सिडर अ ऑब्जेक्ट, फर्स्ट अ इन्क्लाइन्ड प्लेन with height h, length of the path is s, it is inclined at an angle theta. Here is an object which is kept at this highest point. If we release that object, it starts moving in downward direction with two types of motion. One is translational motion like this, and second is rotational motion. So this rolling motion of this object will be combination of first translational motion, it is linear motion with velocity v, and then it is again a combination of rotational motion with angular velocity omega. So here object, consider that object of mass m, it is rolling on inclined plane with height equal to suppose h. The inclined plane is, that surface is inclined at an angle theta. Let v be the linear velocity, then omega be the angular velocity, capital I is equal to moment of inertia of that object, whatever it may be. It may have regular shape like sphere, ring, disc, cylinder, so on. So this is moment of inertia. Let capital R be the radius of that object and K be the radius of gyration. Radius of gyration. Then we have I equal to m into k square. This is the moment of inertia of the object in terms of radius of gyration. So these are the physical quantities required. So consider first object is placed at the end of at the highest point of inclined plane, which is inclined at an angle theta. Height of the plane from ground surface is h. This object has mass m. Height of the surface is h. Inclination angle is theta. Its velocity is v. Initial velocity is 0. Its final velocity becomes v at the bottom point. Omega be the angular velocity while rotating about its axis. I be the moment of inertia. R be the radius. K be the radius of gyration of that object. And I equal to m into k square, where I is moment of inertia in terms of radius of gyration. Now, as we have seen, this total energy of this object is combination of two type of energy. So, total kinetic energy is equal to kinetic energy translational plus kinetic energy rotational. It is combination of translational kinetic energy and rotational kinetic energy. So we can write here capital E is equal to kinetic energy translational plus kinetic energy rotational. So therefore capital E can be written as kinetic energy translational. It is equal to 1 by 2 capital M into v square, where m is the mass of object, v is final velocity of object, plus kinetic energy rotational is 1 by 2, it is I omega square. So we can write this I in terms of k, and also we have relation v equal to capital R into omega. Therefore, omega equal to v by capital R. We have these relations. So instead of I, we can write m k square, and instead of omega, we can write v by R. Therefore, this total energy becomes half. Here it is capital M into v square plus 1 by 2. Instead of I, it is m into k square into, it is v square upon r square, as omega equal to v by r. So what is the common part here? It is 1 by 2, m v square is common part. So we can write this as capital E equal to 1 by 2 capital M v square in bracket. Here it is 1 plus, here it is k square by r square. So this is relation for kinetic energy of rolling body. So kinetic energy of rolling body in terms of radius of gyration and radius of the object is, it is 1 by 2 mv square 1 plus k square upon r square. So this is total kinetic energy of the object which is rolling on the surface. Expression for kinetic energy. Now we have to obtain the expression for velocity of the object, rolling object. So now here for velocity. So this is expression for kinetic energy of rolling body in terms of radius of gyration and radius of the object, radius of that body. So we have to obtain expression for velocity now. See here carefully. At this highest point the body is just kept at rest, means its initial velocity is 0 and it has some potential energy at this point. So it has some potential energy. When it is allowed to roll, this potential energy get converted into kinetic energy. But that kinetic energy is which one? Kinetic energy of a rolling body. So here we can apply the principle of energy, that is total kinetic energy equal to potential energy. This total energy is capital E is equal to potential energy is, that is PE. We can write this as. But this total kinetic energy is this one. So we can write here it is 1 by 2 capital M V square in bracket 1 plus it is K square by R square is equal to, what is potential energy? It is M into G into H. See here, M get cancelled. So finally we can write this velocity as, therefore this V square equal to, here remains this M and this M get cancelled. Here is G into H, total divided by this 1 plus K square by R square. So this is expression for V square. So finally we can write here, therefore this velocity can be written as, it is square root of 2 again here, it is 2 into G into H. So here 2 into G into H divided by 1 plus K square by R square. So this is expression for final velocity of the rolling object. The object is rolling from this point with initial velocity 0 but having certain amount of potential energy. When it starts rolling, its potential energy get converted into total kinetic energy of a rolling body. Total kinetic energy of a rolling body is this one. So we can total kinetic energy at bottom point must be equal to potential energy at this point, since potential energy get converted into by principle of energy, kinetic energy and work done. So total energy, kinetic energy equal to potential energy. So E equal to PE. So writing this relation we can write obtain expression for V equal to square root of 2 into G into H. Again in this case we have to consider here in the figure that sine of theta equal to, but the sine of theta equal to, it is H by S. Therefore instead of H we can write S into sine of theta. Instead of H we can write S into sine theta. Also we get another relation in terms of sine theta also. So the same relation can be written as here. It is equal to 2G S into sine of theta divided by is 1 plus K square by R square. Same relation can be written as. So this is expression for velocity in terms of acceleration due to gravity, displacement covered by the object, angle of inclination, radius of gyration and radius. Now we have to obtain expression for acceleration here. For acceleration. Here it was for velocity. Now we have to obtain relation for acceleration. Here we have to apply Newton's that is kinematical equation number 3. So starting velocity is 0, it covers some path, its final velocity becomes like this. So using third kinematical equation, it is v square equal to u square plus 2as. So what is u? U equal to 0. Therefore we can write v square equal to here 2as. But again, S can be written in terms of H or the same relation. So here we can write, instead of V square, write this one. So therefore, this 2AS is equal to, in this form, velocity square, V square equal to, it is 2 into G into H divided by this 1 plus K square by R square. So here 2 get cancelled, but again H equal to that S into sine of theta, put H equal to S into sine of theta. So finally we can write this as 2 to get cancelled now. A into S equal to here G into S into sine of theta divided by this 1 plus K square by R square. Again this S get cancelled and acceleration can be written as, therefore finally acceleration equal to G into sine of theta divided by this 1 plus K square by R square. So this is the important relation for acceleration of the object. This was total energy and this was expression for velocity. So this is relation for A equal to G into sine of theta upon 1 plus K square upon R square. So this is expression for acceleration of rolling body, velocity at the bottom point obtained by that rolling body, and this is total kinetic energy of rolling body. Here we have to apply one remark. For any object of regular area, means it may be sphere, it may be hollow or solid sphere, it may be a ring, it may be disc, it may be solid cylinder, hollow cylinder. For such a regular body, suppose capital I equal to n times capital M into R square. N may vary from object to object. For disc it is 1 by 2, for sphere it is 5 by 2, hollow sphere it is 3 by 2 or 2 by 2. That we have to obtain in next lecture. We will study the values. For ring it is only 1 by just mr square, for solid cylinder and so on. So I equal to, suppose n into mr square, but I equal to m into k square equal to n into capital M into capital R square. So finally we can write this as k square R square equal to only n. In general, if you know the name of this object, you can find out n. So using this value, we can write velocity and acceleration. So therefore V can be written as, using this part, its velocity equal to, it is 2gh divided by 1 plus n, and this acceleration can be written as, here g into sine of theta divided by 1 plus n. So these are the, again, very important relation for using these formulas in solving objective type of questions. So it is velocity in terms of n. Suppose for this it is n equal to 1 by 2, for sphere it is 2 by 5, hollow sphere it is 2 by 3, for ring it is just 1, and so on. Using the values we can find velocity and acceleration of the respective object. So this is expression for first kinetic energy of rolling body, then velocity of that object and acceleration of the object. So these are relation. There may be question for 3-2 marks on this article, and there may be numerical on any of these formulas. So we must remember kinetic energy of rolling body. It is combination of translational and rotational kinetic energy. The velocity, acceleration in terms of angle also, in terms of k square and r square. Instead of k square by r square, you can write n for each regular type of body, and then relation becomes v equal to. Again we can find the ratio of different kinetic energy. Translational kinetic energy equal to total kinetic energy, rotational to total, purely rotational to translational, translational to rolling, and so on. That ratios are given in your book. You can study, you can solve the examples, and you can find out the ratios for different objects. So this is kinetic energy of rolling body. First kinetic energy of rotating body, and then kinetic energy of rolling body.